Chapter number 14.2, y equal e to the power x. We'll discuss this y equal e to the power x. Now, we know that y equal 2 to the power x is an exponential function. Y equal 6 to the power x also exponential function, constant, and y equal 2.71828 to the power x also this is a constant and positive constant, and an exponential function y equal 1000 to the power x is an exponential constant. Now for this is value, so this is exponential function, and for this value we give a special symbol. If you see in exponential function this value, then we will refer this value as e. So instead of this one you can write e. So y equal e to the power x. What is is e to the power x? What is y equal e to the power x? It is y equal 2.71828 to the power x. So what is the specialty of this number? We'll discuss now. You can remember function and the gradient function. Just to revise you, so y equal x square, if you take, this is a quadratic graph, and what is dy by dx? This is 2x, so this is also a graph. Y equal 2x graph, so this is a linear graph. This is a linear graph. We discuss how geometrically how do we find the gradient graph. Okay, so this is the graph. If I want to draw a gradient graph, then we'll take this x value, x equal, let's say 3, and we draw a 90-degree triangle, and we find the gradient for this one, then 3, and when I divide this distance by this distance, I'll write this value. Then I'll go to next one, 4. Then I'll draw another triangle. Right, when it is 4, then I'll measure this distance and distance, this divided by this, then I'll get another value. So likewise I can plot a graph and the gradient graph in the same graphs. So I plot here graph and the gradient graph in the same graph. This is graph and this is gradient graph. So we are going to do we are going to plot the graph and the gradient graph of this exponential functions. So if you take y equal 2x, then we are drawing the gradient graph also, same graph. Likewise this is y equal 2 to the power x, and I draw y equal 3 to the power x. Then I draw the gradient graph. What I notice here, when it is 2 to the power x, the gradient graph is below the curve, and 3 to the power x, it is above the curve. The mathematicians noticed this, did the experiment, and they found out when this 2 is increasing, this value is increasing, a value is increasing for a particular values, a is below, gradient curve is below the graph, and for a special value it is above on the graph, and for other value it is above the graph. If I explain this scenario differently, this is y equal 2x graph, and this is the gradient graph 1. Then I increase this one. Instead of 2x, I'll put 2.3x. 2.3x, then this gradient is coming closer. Then mathematician put more, 2.5. It is getting more closer, 3. Then they found out when they insert 2.71828, the graph and the gradient graph overlap, and then they start increasing again. So 3. Then what will happen? When graph value is 3, the gradient graph is go over 5, and then this is 7. It's like this. So what they did was they put different values. They start with 2, 2.5, 2.6, then 2.7, 1828, and then 3, and then 7. So they found out when you put this value, the graph and the gradient graph overlap. For below this value, it is below the graph. And for above this value, it is above the graph, gradient graph. For this value, it is overlap. So this is a special finding. What is happening? Gradient graph means dy by dx graph. So y equal e to the power x. This is the graph. And dy by dx graph also e to the power x. So this is a special scenario. Or if I explain like this, the mathematician found out y equal to 71828 power graph, and the dy by dx of this graph also 2.71828x. Hence, they gave a symbol to this value. What is that symbol? E. So then instead of we are writing this one, y equal to 0.718, we'll write ex. And dy by, so y equal ex. And the gradient graph, when you differentiate this graph, still its overlap is still the same. Now if I ask this question, why y equal ex is exponential? Not because of e, because it follows the definition. What is the definition? This value has to be a constant. Yeah, it is 2.78 and it has to be positive. Yes, it is positive value. Not because of e. Because it follows the definition of exponential function. And the conclusion is dy by dx also same. Now what will happen? Y equal e to the power, okay, we'll write the definition. For all real values of x, fx equal ex, then if you take instead of y fx, then f dash x ex. So if you take this as y, then y equal ex, then dy over dx equal ex. And now if you see instead of x, y equal 3x, how do you do? So then dy by dx equal 3e3x. If we have y equal e to the power minus 3x, then dy by dx equal minus 3e minus 3x. The specialty about when you take dy by differentiation of exponential in terms of e, so since the same graph, you will get e equal 3x, and especially, then extra you will get 3. In other way, what is the differentiation of e equal 3x? You write same one and you write the differentiation of this one, 3. And what is the differentiation of e equal 3x? You write the same one, then what is the differentiation of minus 3x? dx minus 3x, what is the answer? Minus 3. Now what will happen? Y equal to 4e3x. 4 is a constant, so disregard it. It means leave it separately 4. And when you forget about 4, how do you do? This one. Write e3x and differentiation of this one 3. So this is going to be 12 e3x. This disregard it means we are not dropping 4. Just disregard for a moment and take this exponential part only. Y equal minus 3x, let's say 7, then dy over dx. Leave this 7 separately. So take the exponential part, differentiate that one. So this value is minus 3 e minus 3x. So this is going to be minus 21 e minus 3x. Another extension, y equal e3x plus 4. Then dy by dx equal, address separately. So this is, you know that 3e 3x, and this is 0 when you integrate. What will happen? Y equal 4e 3x plus 5. So then y, you consider this one separately and this one separately. So 4 leave 4 aside, then take the exponent. This is 3e 3x and plus differentiate of 5 is 0. So 12e 3x.